Hello everyone, welcome back. We are still in the chapter 3 about transport layer. Now we are going to discuss about the multiplexing and the multiplexing. Okay, so if we are reviewing the how the web server and web browser communicates, first from the server side, if the web server wants to send HTTP response to the client, it creates the HTTP message with the HTTP headers, and then at the transport layer, it adds the transport layer header, and then it passes down to the network layer, and then the network layer will add the network layer headers, and so on and so forth, and then the packet being sent to the client. Now, what happens if the server communicates with more than one client? How the server handles the message that is arriving from two different clients, okay, and then being transferred to the correct, let's say, process. So this is when the multiplexing and demultiplexing comes to the pictures. Okay, the multiplexing at the sender means that the transport layer handles data from multiple sockets and add transport header. This is later used for the demultiplexing. And then demultiplexing at the receiver side. So the multiplexing is happening at the sender and demultiplexing is at the receiver. The receiver, transport layer receiver, use the header info to deliver received segments into the correct socket. Okay, so how the demultiplexing works, the host receives IP datagrams. So if you recall, datagrams is the term used for the packet in the network layers. Okay, so in each datagram, there are two important informations called the source and destination IP addresses. Okay, and then within the datagram there is a segment. Okay, segment is basically the transport layer packet. Okay, and it contains two important informations, which are called the source and destination port numbers. So basically, the host uses this in total 4, okay, IP addresses and port numbers, source and destination, to decide where the multiplexing or multiplexing, where to redirect the packets, and especially in the demultiplexing. So this is the structure, general structure of transport layer headers. So the most important part is the source port and the destination port. Okay, now we are going to talk about the connectionless demultiplexing, or the UDP, basically. So let's recall the socket programming. If we create the UDP socket, first we must specify the host local port. This is similar both for UDP and TCP, but then what is specific for UDP? When we send into UDP socket, we must explicitly specify destination IP address and port numbers. Okay, so this is different from the TCP socket because basically, if you recall, in TCP, when the server receives a connection from a client, so it creates new socket. Basically, the socket information is already there in the socket. So when basically, if both server client wants to communicate, it doesn't have to explicitly specify the destination port and IP addresses. Okay, so then what happens in the demultiplexing at the receiving host? First, it checks the destination port number in the segment, and then directs the UDP segment to the socket with that port. So that's so basically in the UDP, although the IP or UDP datagram has same destination port, but different source IP addresses or source port numbers, it will be directed to the same socket at the receiving side. So so basically, the deciding factor for demultiplexing in the UDP socket is only the destination port numbers. Okay, so the other three information, the destination and source destination IP address and the source port numbers, do not really let's say give significant information. Okay, so this is the example. For example, there is application with the using port number 9157, and then another application with the source port number 5775, and then this is the server with the port number 6428. So from the first application, or the P3, the process number 3, it uses the source port is 9157, and destination port 6428. And also, I mean, like if the process 1 has to respond to the process 3, the source port and destination port is just being inverted, okay, or reversed. And then for the communication between process 1 and process 4, so basically when the process 4 sends the packet to the process 1 application, the source port will be 5775, and the destination port number is 6428, and then the other way around for the message sent from the P1 to the P4. So basically the main message here is that at the P1, okay, at the server, it only provides one socket for the same port number 6428, which is, I mean, it is used as the destination port from both P3 and P4. Okay. Now let's have a look what happens at the TCP. Okay. So TCP socket is identified by 4 tuples: source IP address, source port numbers, destination IP address, and destination port number. So we'll use all 4 combination of these 4 values to direct to the correct or appropriate socket. Okay, the server may support many simultaneous TCP sockets. So for example, if a server, let's say web server, it serves, let's say 10 clients, 10 different clients, so it has to open 10 different sockets basically, and it has to be simultaneously done. Okay. So for example, we have one HTTP server communicating with 2 hosts, but then in one host there are 2 processes, different processes communicating with the same HTTP server. So this is something which is quite common in our daily life. Like for example, we are opening 2 browsers, 2 tabs of the web browsers to communicate with the same website. For example, like for example, if you are accessing I don't know, let's say Skelly or any website, first we check the one page, and then we use different tab to check the other page, right? So these are considered as 2 different processes. Okay, so basically in the main point in this connection-oriented demultiplexing or TCP socket, the server has to use different socket for different process. Even, for example, in this case, this host C, for example, it has the same IP address, okay, the same IP address C, for example, but it has different port number. Okay, so if you take a look at this, the destination port, the destination IP, destination port are the same, B and 80, and also it has the same source address C, but then it has different source ports. Then the server has to open 2 different sockets for host C, for example. And for host A, although it has the same destination IP and port number B and 80 as the other 2 processes, but then it has different source IP address and source port number. So or let's say, and if we have a look at this, it has the same port number 1957 with this process number 3, but it has different port number, the different source IP address. This one has IP address A and this one has IP address C. So the communication with the P1 has to be handled by different process at the or different socket basically at the server side. Okay, so this is the main differences between the connection oriented or TCP socket with the UDP socket at the demultiplexing. So summary, multiplexing demultiplexing based on segment and datagram has values. In UDP, demultiplexing only relies on the destination port number only. And while in TCP, demultiplexing using 4 tuple source and destination IP addresses as well as port numbers. But in general, demultiplexing and multiplexing happens at all layers. We are only talking about the transport layer here, but essentially it also happens at the network layer and below. Okay, so I think this is all for the second part. We are going to continue with the connectionless transport layer UDP in the next video. So see you in the next video.